Okay. So I tried the problem like 3 times. I used different calculators, and I know that I looked at the answer key that I was working off of, and it didn't match. I can't figure out what's going wrong, so we're going to go with the answer that we've got, because everything we're doing is the right process. So we had that. So remember when we do the derivative of a parametric, we do the derivative of y over the derivative of x. And that's what we put in. Remember, we did a control divide, and then we did menu, calculus, numerical derivative at a point. We switched our variable to t because we were in parametric form. And then we put in the value of 1. And then we went to var, y1, and then you have to put the t there. If you put an x, you'll probably get an error. And then menu, calculus again, numerical derivative at a point. Switch it to t, value 1. Click OK. And then var x1 of t. And then you can hit enter. I'm going to give you a minute because I know that even though we did the same calculation yesterday, it doesn't hurt to do it again because you got to get that muscle memory of what buttons you have to push in the calculator to do this. And yet again, we get negative 1.582. So we're going to go with that number. So that's the number I'm going to use in my notes. Okay. So the next thing I have to do is I have to get the position of the particle. I'm not in the right spot here. So actually read B to yourself really quick. And I want you to think about what you would do with it. Even if it wasn't parametric, what would we do? Okay, so what's it asking us to find? Position, okay. Position of what? Position of only the x coordinate. So I'm only messing with x, okay. Where is it want that position at what time? 3, okay. But remember you told me yesterday, what did we have to begin with? And that we always have to be careful of when we're talking about position. An initial condition, okay? So this one's a little bit weird and tricky because of it being parametric. When we do our integration, we're going to start here and go to here, okay? So that's the first part of it. So start at 1, go to 3. And we're going to do this of just the x. The dx dt is what's going to get integrated. That seems weird to put. Oh, dt. dx dt. It seems really weird to write this, but this is the way you write it. This is the proper way to write it. Because that's what it says. All right. The thing is that whenever we do initial condition, don't we usually have like a something plus the integration? So in this case, usually it's a y value, right? But in this case, we're talking about the x coordinate. So we would want to use the x coordinate from the initial condition. So we would do 2 plus the integral from 1 to 3 of dx dt dt. All right, at this point, it's calculator work. Okay, so let's work on putting that in our calculator. We could just be, you were using the same function that we know that it's in x sub 1. Okay, I'm going to go 2 plus. All right, how do we get an integral in there? Yep, shift plus. We can't forget that, right? We're getting too close to the test. We need to have that down. 1 to 3. And then you're going to go var x1 of t dt. And go ahead and hit enter. We get 4.158. Okay. Oh, that did not paste where I wanted it to paste. At all. Get it together. There we go. All right, so that finishes up topic 9.2. All right, and I know that I put an assignment out there. I put answers out there. There's answers out there, good, better answers to that first assignment from 9.12. Okay. All right. So we're going to look at 9.3, and literally there's only like 2 examples to this. I think it's going to take us